So as I said, my name is Anjali Bajaj and I am hosting, and the introduction would go, welcome to Women Who Code event. So our mission is to empower diverse women to excel in technology careers. Our vision is a tech industry where diverse women and historically excluded people thrive at any point. Now over to Prachi, who is our speaker as well as the instructor. And a senior software engineer director at Women Who Code San Francisco.
Hey everyone, can you hear me? Great. So hi everyone, I'm Prachi Shah. I'm an instructor and a senior software engineer with close to 12 years of experience in the industry. And I'm director of Women Who Code San Francisco for over a year now. Welcome to Backend Study Group. This session is the last session of the year. We started Backend Study Group like 2 years ago, and every month we talk about different concepts, and we also do demo, look at code, etc. Today's session is about Git and version control systems. We'll understand what version control means, what's Git, and introduction to some Git commands. We will understand Git Flow workflow, and then at the end we will do a Q&A. But feel free to submit your questions in the chat. Also, just to note, all these presentations that we do every month are on our Women Who Code GitHub page, so you can always go back and refer to our demo code, our presentations. And this recording will also be on YouTube, Women Who Code channel. So I always like to talk briefly about what backend engineering is before any topic. So backend engineering basically is anything that the client or a front end or user does not usually see. So it pertains to designing, building, and maintaining server-side web applications. Some of the common terms in this domain would be, understanding like client-server architecture, networking, APIs, different web frameworks, platform microservices, databases. You need to understand web fundamentals, knowledge of operating systems, etc. The tech stack usually is Java, PHP as backend or server-side languages, .NET, C#, Ruby, Python, REST, AWS, and Cloud Fundamentals, as well as NoSQL, and the list is big. Some other domains that somewhat overlap or related to backend engineering is front-end engineering, full stack, design, and user experience. This is when you're designing backends for different products, mobile development, DevOps engineering, machine learning, the list just goes on. So let's understand what version control is, right? First, we need to understand version control, source code management. All these things are somewhat synonymous, and depending on the software you're using and depending on how much experience you have in the industry, you might have already known these terms and stuff like that. So we need to first understand what source code is. So it's basically a collection of code or programming statements written by a software engineer, right? So when you're writing code in an IDE, in a particular language, all that is considered like source code. Usually it's high-level programming languages, but these days, all sorts of code is version control. So it can be, like a JavaScript code or your PHP, Java, Scala, the list just goes on. So source code is just the code or programming statements that you write in a chosen framework and language. Source code management basically then means is a process of tracking and managing code changes in your projects or your applications. So what we do in source code management is we log a history of continuous code development, right? Any changes to your code, any code manipulation, we want to keep a history or a log of all those changes over time. Contributions made by different developers, it can be multiple developers belonging to different teams can be working on the same project and in parallel or synchronously or simultaneously be contributing to the code changes, right? right? We want to track all of that. Source code management also helps us identify code dependencies and resolves code merge conflicts. So, let's say two engineers are working on the same piece of code and they're contributing continuously. This will help us, resolve any kind of merge conflicts, or make sure that because we have a log, we can always go back and trace the changes made and resolve any simultaneous code changes, conflicts. So because we have a history and a log, source code management systems allow us to revert to previous a good version of code. You commit something, let's say it introduces some bug that you didn't know of, or in a certain piece of the code of the project that you were not aware, you can always go back to and revert your code to a previous good version, and then do your research around, what is happening. Tracking makes it fast and efficient to track like breaking changes, like I mentioned, right? Any kind of code bugs. You can always say, yesterday I committed a code and today I committed on some more code, but now I'm having all sorts of issues. So I want to revert to yesterday's commit and or yesterday's code and then research, right? Like what changes I made and what's the effect of those changes. Development teams can collaborate, get feedback, and assert quality. So the way these modern source code management systems are, it enables developers to collaborate, understand code, provide each other quality feedback, and help with testing as well. Source code management has now become over the years just super crucial in the development phase of development part of the software development life cycle, because all these modern tools and applications have really enabled an efficient source code management or control, and really improve the developer collaborations among different teams as well. Some of the well-known source code or source control management systems are GitHub, GitLab, Mercurial, Microsoft Team Foundation Server, Subversion, Bitbucket, etc. We're going to focus more on Git and GitHub in this session. So we need to understand what Git is first, right? So Git is basically like a free and open source distributed version control system. It basically has like a global information tracker, which tracks changes in a collection of different files. So different files, meaning it can be like a Java file, or, a PHP file. If your project uses different technologies, and those will be corresponding to different files. It can help you manage all sorts of files in a particular project. This is a distributed system where developers can clone the whole repository and view a history of changes. Repository here just means a collection of projects, and each project or application just has code in it. A branching model for creating multiple local branches for independent code development, right? So it helps us work on creating different copies of your original source code, so different developers or teams can focus on their own version of the code and do independent development, do testing, etc. This whole process just has contributed to faster development, more efficient and independent testing, shipping code faster to production as well. And Git is basically supported by all sorts of VCS systems, including GitLab, GitHub, Bitbucket, etc. Git repository, like I mentioned before, is just initializing a project with Git to enable version control and tracking. So if you, let's say, create your own project independently, any IDE usually, if you need to do version control, you need to use Git, and Git is basically provisioning your project or your application for version control and tracking. GitHub then is, Git server as a service. Basically, it's a platform which supports Git and gives you all sorts of features out of the box, so you can, version control your source code. It's an online platform, so you just can go to github.com and just start. You can have your project, make it enable it with Git, and just you get all features of the GitHub platform. It's basically a cloud-based hosting service to manage Git repositories. So your code is on a cloud server, which is your GitHub, and different people can access it and manage the code as well. GitHub basically, because of all its amazing features, has just enable different access controls, continuous integration, code feedback, continuous development for testing, etc. And it has come up with, it's basically, it introduces a new concept, which is, continuous integration and continuous development, where you can keep on continuously submitting new code. It gets integrated in your repository, and different developers can, check out latest code immediately and start contributing. So it has really made the development process, development testing process super efficient. Like I mentioned before, GitHub, they are supported by many different languages and frameworks, and Git is just a tool, and GitHub, is a service for projects that leverage Git. And in a nutshell, we need to understand some terminologies when you start, let's say, enabling your project with Git. Repository, like I mentioned before, you just initialize your core project, and what it does is, it creates a Git folder inside your project folder, and this will help Git or GitHub to track all the changes and different build versioning as well. Changes here mean, you added a new file, you deleted some files, you rename files, you update files, and you modify some code, or even if it's a text file in your project folder and you modified it. Any kind of file changes, code changes are all tracked. And this is what Git does. It's not just I deleted a line of code, right? A programming statement that counts as change, but I deleted a file or I renamed a file, all that also counts as changes. And Git will track all of this. Blob, so we need to understand what blob is. Basically, it's just a binary large object, and it's a data structure that represents contents of a file. So internally, Git uses, a tree structure for maintaining, for basically storing all your project folders within all repositories, and files are basically blobs. So that is the core data structure for Git. And like I said, tree, it's a directory structure and points to blobs and files. So that's how all your projects are stored internally. And that's the data structure that Git uses. Snapshot. So snapshot of code changes is basically, it's your code or your files, the status of your files or your code at a given point in time. So, right now, I'm not making any changes to my project. It's one snapshot. After 5 minutes, I submit some changes. Then it's a different snapshot in time, right? Then you can always differentiate between snapshot at time t and time t plus 5. So the snapshot is just the status at a given point in time. GitHub uses Historian for, again, tracking differences. Commit is basically, commit is a creation of a snapshot. So every new snapshot change creates a new commit. Commit is basically, you have your code in your local IDE or your local system workspace, right? You're making some changes, but nobody else in your team or the other collaborators you're working with know about the changes you're making locally in your workspace, right? So you need to push your code and upload it to Git, and this change between the previous good state of the project and the changes you made counts as a commit. And once you commit your code, you can see all those changes on the GitHub online platform, and you can add different people to that project, and they can now see the difference of the changes that you have submitted. So, and every time you submit changes and you basically upload or push your code to your project repository on GitHub, you are basically seeing a difference of the previous and the current state of the code or the files of the project, basically. GitHub has a concept where, there is a main branch, and main branch is the most up-to-date snapshot, I guess, of your project, which is a it's in good standing, and that is the branch, or that is the code you would probably want to use for testing, or you want to basically deploy to production. So it's the most supreme state of your project. It's the default branch name as well for GitHub, and it's just like a snapshot of your code that you would want to deploy to production. Branch then means a clone of this main branch for custom development. So you have your code project, which is in production, and now you want to add a new feature. You won't modify the actual copy, actual main branch, right? You'd want to check out your main branch, create a separate branch out of it, which is just a copy of your main branch, the default branch. And then you want to make changes to that copy of your code for development, for testing, for bug fixing features, whatever your purpose is. So usually developers, call that like a feature branch. If you're adding new features, you can also call it like a bug fix branch, because you are, the whole focus of that basically checking out of the main branches to fix a bug. So depending on what your purpose is, you would want to, branch out. Head is just the name reference to the latest commit in the branch. So, let's say I created a branch of a main branch to add some feature, and I'm pushing like 10 commits because I'm making changes back and forth. I'm going back and forth, or I'm just adding, little pieces of code at a time. So do this copy of my branch, I push 10 commits. Head would be the latest commit in that branch. Head revision is basically the most current version of the code in that remote repository. Tag would be, you can mark a commit in a branch for logging important commits. So let's say I put 10 commits, 3 of them are like most important. I would want to tag them. Say, hey, in this commit, I put a security fix. In this commit, I, put something else. So if I want to name a commit, tagging is the way to go. That way, when I see a log, I actually know what exactly I did. It might be helpful for me to go back and see my code a year down the line to track what changes I made. It will also help other people, other developers who are working on that project to just understand, when the changes were made and what that meant. So you help your fellow developers with understanding, all the important main changes that were done by you over a period of time. Rollback or revert current changes. You basically roll back or revert current changes to a previous commit. So let's say I push my 10th commit and I broke something because I didn't test properly, right? I want to revert it to the previous commit, which is the 9th commit, and it ensures that, I didn't break anything now because of my last commit. So I can go back and roll back to my previous good commit. And because we have a history of all the commits and all this is logged, the GitHub platform provides this great benefit to always roll back your changes to the previous good commit or previous good version of your code. It's a really good feature, and developers do this many times, especially when they're testing. They would testing something very complicated and there's a lot of dependency, they would want to sometimes roll back and compare the effects of the changes they're making. Merge and merge conflict basically is, all sorts of development changes can be integrated at the same time in the same branch by different developers because they can just create different pull requests. And what you want to do is, you want to merge all these different changes at the same time. And that's something that merge takes care of. And merge conflict is, let's say I am working on this branch, I create a PR and I'm changing something on line 10 of a certain file. You are doing the same. And now we have different versions of that same line. GitHub will tell us there's a merge conflict, that there are different conflicting versions of the same piece of code or line, and GitHub will prompt it, and then you can resolve those things. Pull request then becomes, basically it's a feature where a collection of commits or proposed changes you can see that on the GitHub platform for all developers to review. So I can create a pull request which has a list of all my changes, all the files, the diffs, the previous and new code. You can see all my commits, and I can add other developers in my team, and they can see the code and they'll understand all the changes that were made. And you can also add comments around or description around, hey, this is the change I made. This is the reason why I made the change. This is how you can test it. These are the tests I added. This is how you can deploy it. And any other notes or diagrams or documents that I can link, I would want to do all of that. So basically, you're just explaining all your changes to your fellow developers for them to review. You cannot just make changes in a local workspace, and as everyone knows, right? So GitHub gives you an option to propose some new changes and put it out there on the platform for everybody. Well, for anybody who has access to your repository, to usually it's within the org, to look at those changes, give their feedback, approve the changes, reject the changes, and just give their feedback and comments for improvements in general. And once all the reviewers and the author are in sync with the changes and it's all tested, then you usually get an approval on a pull request. And that's when you get a green light to now push your changes from your specific development branch to main branch, because your proposed changes are now approved. And once it's on the main branch, then you go and then deploy that main branch with the latest approved changes to production. You never usually deploy your development branch to production. It just always has to merge to your main branch, which then becomes the latest state of your project. And that is the one that needs to be deployed to production always. And this is just a process and a best practice that everybody across companies and people who use Git or GitHub usually follow, or version control usually follow. We'll look at some commands quickly, as into like how you can initialize your project to make it a Git repository, and then some commands that you can run in your local terminal or even a terminal in your IDE to just experiment with Git and understand the Git flow. I'm going to assume a Mac operating system here, but the commands usually are the Git commands are usually the same. So you can just install you can just do a brew install Git. That will help you install the software into your system, and then you can install its GUI too. There are two ways to leverage Git. One is in your terminal, you can just run commands. Other is like there's a Git GUI tool or software, which also you can use. I prefer the terminal, but engineers have different preferences. So whatever works for you. Usually need to have like a GitHub account. You can create a free account, and you should be able to start adding repositories on GitHub. Once you have your project in place, all you need to do is you need to within the project folder, you need to, at the root level of the folder, you need to run the command git init. All that does is creates a .git folder and initializes your project for to basically support Git. Now your project is enabled with Git, and as you start making changes, and once you have your Git command line install or GUI install, now you can basically leverage the power of Git and version control. Any changes now that you make and any commits you push using Git commands, you would be able to see your repository on GitHub. The first time you push something, you will now see your repository on GitHub. And then when you start committing code and uploading or pushing it to GitHub, you will see all your changes now. Everything will be tracked. So now your project is Git enabled, and you should be able to see it on GitHub as a repository or an application. Cloning an existing, if you already have a Git repository, let's say you want to learn Python and someone on GitHub has, already created a project where they teach Python and something hands-on, you can always download their code, which is Git enabled, and you can learn it by yourself, right? So what you can do in that situation, in this example, is you can create a Git repository, initialized project with a Git hosting platform like GitHub. You can just basically clone that repository, and you can run the git clone command locally with the URL of that project. Basically, any project you have on GitHub, you can get a URL like HTTPS and the whole URL to that project. You can just run a git clone and the URL of the project. What that does is it downloads the entire project to your local workspace or the folder you're in your laptop. Or you can just do a download, zip download. There are different options. You can also do an SSH. So depending on your preference. And then this basically creates like a development branch for you to add new changes. You can make changes, you can commit changes, you can create pull requests. So, let's say I join a company and, my first task is to make some small change, right? I can just download the code that exists on that company's GitHub repository and create a pull request out of it and submit my changes, right? So I don't need to create everything from scratch. The the repository is already on GitHub. I just need to clone it, make my changes, submit a pull request, and people in my team, engineers in my team would be able to now review my changes. And then feedback is applied. And then once the pull request is approved, you can basically merge it to the main branch, which is then set up for deployment at a specific date that you or the team can decide. If you need to create a Git repository, so these are some very common Git commands. Like I usually do like command line, but if you have a GUI, you probably don't need to necessarily know or understand these commands. But like if you're starting to understand GitHub or version control, I highly recommend just knowing these commands and at least use them. So at least you're familiar. I think having the knowledge of some base commands is crucial. So like I mentioned before, right, like if you want to initialize a project to use Git, you can just do git init, run that command in the terminal, and it's basically in your project folder, but at the root level. This will create a head and default to main branch. So that copy of, or that state of your project then becomes your main branch. And then it initializing also adds a .git subdirectory to your project. You can clone a repository, we talked about that. Creating a branch would be like, git checkout -b and the name of my branch. So it can be, like my first branch, right? I can just call it that. Or usually it's Jira number, or usually you just explain something like, security bug fix, whatever. You need to name a branch. It's basically a development or bug fix branch, but you need to usually give like proper name to the branch. You just cannot just say like like branch B1 or branch B2, nothing like that. Just it's usually something like git checkout -b means you are creating a new branch off of the main default branch, and then you give a branch. So I would be like security fix, or adding a new API to do so and so, something like that. And this will create a new branch copy out of your main branch in your local for your local development. -b means, again, creating a new branch. If you don't use -b, git checkout branch name would basically download this particular branch that already exists in your local workspace. So let's say let's say your company has a Git repository, right? And let's say some engineers in your team have created some development branches off of main, and you can see that, right? Because they have created a pull request, submitted their code, so you can now see their branch. If you do a git checkout name of any of their branches, now your local workspace has a copy of their branch because you didn't do a -b. So that way you can download an existing branch and you can test their code, get their PR and stuff like that. There's a concept of like staging changes, which means that any changes made to the files, your code or project, they should be staged for pushing or uploading them to GitHub. I can make all sorts of changes in my local workspace in my Git project, but I need to stage them in preparation for creating a pull request. Then I have made a commit, and then now you can see the difference. Otherwise, if I'm not staging, then all those changes stay local. None of that code is pushed to this new branch on GitHub, and nobody can see it because it's all still in my local workspace on my laptop. So it's not staged for review or, basically for review. So what you do is any changes, right? Adds, updates, renames, deletes, etc. You need to do a git add, which basically stages all your files in preparation for a commit. A git add dot means any changes across the project are staged. If you do a git add, like my first Java application .java, then it will only stage that particular file for commit. All the other changes will be ignored and they won't be pushed to commit. So you can choose the files you want to add, or you can just push to stage all changes using like the dot. Commit changes, usually any change you push or upload to GitHub is called a commit at that point, or it's just an upload of your code on GitHub to that specific branch. And that process or that concept is like commit, and a git commit is the command to do that. And usually you need to like, it's always recommended as a best practice to like name your commit. It can be as simple as, address PR comments, or deleted XYZ file, or renamed XYZ file, or I added like one test. Whatever you do, if you're pushing something to, if you're committing something, always rename it in a way that's simple, but like very specific. So other engineers or reviewers in your team kind of know every commit that was made, what is the difference and what changes were made. So always be very, you don't need to write an entire paragraph. You need to be, very specific and clear as to what changes in every commit you're doing. It's always recommended and really appreciated by reviewers of your peers and commits. Git push, then what it does is, now that you have staged all your changes, you have named that change, you can now push that branch to GitHub online, right? So basically, you are now uploading all your commits, all your changes remotely. You just had it in your local workstation. Now it's pushed to the same branch on GitHub, right? And it will sync everything. And then anybody who wants to look at what you're doing, even create a pull request off of your branch, is now able to see it, because it's online for everyone to see, review, download, test, etc. And this helps you collaborate. And you can literally say like, hey, like my fellow teammate, hey, I pushed something 10 minutes ago, can you review it? They'll review it, they'll be like, hey, can you make small changes? Okay, great. You can again push a commit with their feedback. They can immediately review it, test it. In 15-20 minutes, you have, great collaboration done. And now you can independently test your changes. They have access to your latest code. They can also review it, test it, etc. So this really makes the whole collaboration process, feedback process, fast and efficient. It's working with engineers in a team is simplified. What next you can do is, once you commit, you can now create a pull request, which is just a page online on github.com, basically for your repo, branch, and commits, where you see a history of commits, all the files changed. You can add reviewers. You can even link your build jobs for it, which runs automated tests and stuff like that. You can explain. There's a comment section. People can add comments. You can write description. You can do all sorts of things to support or explain what you're doing in that pull request for others to review, question, comment, approve, reject, etc. And you can build all sorts of other external tool integrations through GitHub to just run your static code analysis, your testing, your build jobs, your deployments. All of that is pretty much built in, all these integrations, which you can do it as well. Git fetch basically imports commits to your local branch. Some other commands, commands would be git fetch to import commits to your local branch. Git pull would be like, let's say you and I are working on the same branch. You push something which I need to also now refer to, right? So I'll just do a git pull for that specific branch. So your changes are now locally downloaded. And now I have all the latest changes that you made, and now both of us can work on the same copy of the branch, right? Because I pulled or downloaded the latest changes from the online GitHub repo to my local workstation. Git status tells me a list of all the changes that I made. It will tell me that this file was deleted. It will mark it as red color. If I added a new file, it is marked as green color. If I renamed the file, it will tell me that this file was renamed from X to Y, right? All of these things, it's like color coded. So Git status tells me all the changes. So whenever you commit, or whenever you are just adding or staging your changes, basically just always do a Git status to understand, do you have the latest code? All your changes are there. You understand all the changes you're pushing. Will you have a merge conflict, or your staging is good to go? So Git status gives a lot of information. And the last one would be like Git diff. This is like if you were really hands-on with like using Git commands and you're very comfortable with terminal, you can do a Git diff. which basically gives you like, like a diff of all your code changes right there in the terminal. If you're making small changes, it's super efficient. Like I use Git diff like all the time. So you can just see all those changes in local terminal right away, rather than creating like a pull request and then seeing it. If you're using one of those modern IDs, you can totally like use their Git and version control features to do that too. But the most simplest is also just using like a git diff command, and it will show you all the differences for all the files. One of the things that we need to kind of also know is like Git Flow workflow. It's basically like just a note here, like not everybody likes to follow Git Flow. Not every company does it. It really depends on your project and developers and how complicated things are, that you would or you would not want to use Git Flow. And you can always come up with your own understanding or reasons as to why we would want to use this kind of a workflow. So some of the things we should like just first understand before we look into like Git Flow. There's a concept of like remote repository, which we know, right? Like at this point, like it's just all your code uploaded on GitHub, right? It's a remote repository. It's not local in your workstation. So your code is hosted on some GitHub server, right? So it's remote. Local is this local copy of that remote repository, which you downloaded or Git clone or Git pull for your local development. The Git Flow basically just provides like best practices to integrate different branch types. We'll look into that. It's just best used for like frequent development, frequent maintenance, frequent release projects. When you have like one project which is really big, or like a lot of people are making all sorts of changes on that project, you have like 5 teams working on the same monolith, right? And different versions of that project need to be deployed for different environments, right? Like one version on mobile systems, one version let's say on iOS or Android, a different version on the web, a different version for staging and testing. And a lot of people are doing simultaneous development efforts on this monolith or this big project. Using Git Flow will really reduce a lot of headache and confusion when so many engineers are working together on all these changes, and basically are free to deploy their code to production or any different system or environment whenever they want to. They do not have to rely on each other. These 5 teams don't have to talk about what code they are pushing, who needs to review, are they getting approval, do they need to test together, like and this is very common, by the way. It happens in many companies, and like that's why like this kind of problem can be solved with following a Git Flow, and it really falls in the like developer efficiency side of things, and resourcefulness. So most companies, when as the org grows, teams grow, this is something to definitely consider, at least. Basically, I'm showing here is like a development flow diagram. When you follow a Git Flow process, now you label. Now you know what a branch is, right? It's something off of main, and you're creating a branch for a specific purpose, right? Now you would want to name every branch and for a specific purpose. So if I'm creating a branch of main for some kind of new feature development, some non-emergency bug fixes, I would call it like a feature branch. Usually, if I'm creating a branch for just at a particular point in time, I'm creating a branch of main just to release my code to production, then I'm going to call it a release branch. Main is just your default good state or the latest state of state of your code at a given time. Develop is basically it contains all the latest release code which now you can work with. It's not main, but it's release. So your main can be deployed to a different production system. Your release is just something off of main, which is just deployed on a different production system. Like release can go on mobile apps, and main can go on web application, right? You can decide. This is what Git Flow does. It gives you the freedom to deploy a different version of your code to different environments at a different point in time. And develop, usually you don't branch off of main, you branch off of release, and then you can add more changes to it. And once you merge develop your changes, develop is merged to release. It's not merged to main. So that's the difference. And hotfix is basically a hotfix branch would be emergency bug fixes, right? Like you pushed a commit and the system went down. Sorry, you deployed your code and the system went down. For some reason, you broke something. You would really want to either revert such a commit, or if there were effects that you didn't know and happen, then somebody in your team or somebody else in a different team would immediately come up with like a hotfix branch and immediately push a fix, so your systems are restored in like a good state or a previous good state. So this is what Git Flow helps you do. And if you look at the diagram here, right, like different engineers are working on like the same project, but they can branch off of, they can have their own different versions of the code, and that can be used for like different purposes. So if we look a little bit more in detail, we need to really understand like what the purpose of each of these branches is. Like I said, feature branches like for new development, it can be branch off of develop, but it's also usually branch off of main. Completed features and bug fixes are merged into develop branch when release ready. So any kind of feature branch or develop branch basically is for your feature development and your bug fixes. Release branch is created off of develop for retaining and releasing the code. So yeah, so once you're release ready, you want to create like a branch and you want to call it like ideally release branch. And you can have versions like release 1.0 goes to deployment to production today, release 2.0 will go next week. And you can have like different versions of that code branch in different systems, even for testing. So you can like do a lot of versioning here. It gives you a benefit or opportunity to version your code for different kinds of purposes and for different teams to work on as well. Any bug fixes are done. Yeah, so these are some of these things that I mentioned are somewhat custom. In the previous slide, what I mentioned is usually the understanding, but depending on the team and your processes, you can, it's not like super set in stone. You can totally customize, or you can have your own understanding or implementation of the Git flow. So you can, if you have a release branch and create off of develop for retaining and releasing the code, that's totally fine. Bug fixes can also still go in release branch. You can create a bug fix branch and merge it to release, and then the release goes to production, right? Stuff like that. So all this is still is flexible, is what I'm trying to say. When release is ready, it can be merged to main branch and into develop branch as well. So like you have a release 1.0, it gets merged to develop 2.0, which then becomes release 2.0. So like if you're doing versioning, you can merge different branches and different release branch to develop and features and stuff like that. And you can tag these, you can have a version control of different branches itself. Versioning of different branches itself. Main branch, as I said, contains the latest release code. Once you have deployed the release code, you would want to then merge it to main, because remember, main always has the latest code that has gone to production. So you always have to merge it back to main. So main is your source of truth, always. Develop branch contains latest release code, changes for new development, sure. Hotfix branches contain emergency bug fixes. They're usually created off of main branch. And this is the good assumption because your main has the latest code. But if you deployed a release branch today and it's not merged back to main and something broke, you would want to then create a branch of a release code, fix it, and then merge it back to the release and then deploy that. And once that is successful, you merge the release to main. So this basically a Git flow, something like this, really helps you organize in some way all the changes that different engineers are making on your code base, and it gives a lot of flexibility to just even version your branches and really categorize them into different development efforts that you're doing. Like if you look at the diagram here, right? Like master has different versions. 0.1, 0.2 to 1.0, and what it's trying to accommodate is a hot fix. Difference between 01 and 02 was like a hot fix. that was done. But if you go down and look at all the orange dots, all the develop branches only made it to like master at 1.0, not before that. So all those changes are not made then. So you can have all this flexibility as to like, when do you want to deploy? If I want to deploy my develop branch for testing, I can do it. Feature branch for testing, I can do it. Release is only when you deploy something in production, then it needs to go to master. So all of these things is just a flexibility that Git Flow provides. And developers, engineers, or teams can decide amongst themselves what Git Flow processes they want to follow and how do they want to customize or modify it for their own needs. And this is like a super flexible process too, so you can always iterate and learn from this and leverage this Git Flow process as you may, and whatever suits best for your team or your project or your engineering organization. Some of the advantages would be then, like parallel and isolated development, right? Like different people here, let's say in this diagram, are working on different, any dot here is basically a branch. So blue dots are develop branch, gray dots are feature branch. Release 2.1 has its own 3 different branches, right? So different people or engineers or teams are working on all these different dots or branches, and this is all happening simultaneously. The line tells you like a point in time. So this is all happening simultaneously. People are working on different versions of the same project, and teams can decide independently what goes to production, when, on what device, and what environment, and stuff like that. And how would you want to test and monitor all this as well? So it really simplifies parallel and somewhat isolated development across different teams, and therefore also improves like developer collaboration, because everybody's not working on the same branch. Therefore, you don't have a lot of code changes going in done by like 5, 10, 50 people in the different teams. Everyone has their own specific small PR, which is super isolated, which people can review and give feedback and test it out, right? So it really simplifies collaboration, testing, all of these things. Develop branch is staging all features. Release branch is for all recent changes. So once you understand what develop is for, what release is for, and what it means for you, your team, and your organization, then you can really use these terminologies locally within your team and your org, and everyone will understand, right? Like a release branch 1.0, version 1.0 needs to go to production today. Release 2.0 will go next week. You can use these terminologies, and everybody in the team would know. If they go on GitHub, they look for release 1.0, release 2.0, and then see all the changes, all the pull requests. So everybody is able to have a common terminology. They understand all the changes, and then can independently test or give feedback or just discuss, right, within the team, and even with non-engineers, because now you can differentiate between a release 1.0 and 2.0 clearly. Disadvantages are no need for different branches. Like if you don't have like a lot of code, like it's not a monolith, not like 50 teams are working on that code, then using Git Flow, you are just overcomplicating it. You would want to keep it simple. If you have a small team of 5 people who's basically managing a project, nobody else is responsible for it, you don't need Git Flow here. Just creating 1 or 2 PRs and 3 or 4 engineers in the team reviewing is great. You would not want to overcomplicate it. Git Flow is very specific. It's to solve like some specific problems. So you would not want to overcomplicate it. Git Flow will not help you solve any problem here. In fact, it's just like delaying your development timeline. Sometimes workflow for features and hot fixes branches are the same. So sometimes, developers, usually when they're new to it, they get confused between what does feature mean, what does hot fix mean, and a feature branch or develop branch or a hot fix or bug fix branch is all the same to them. So, you have to really as engineers within a team or within the org, understand or agree upon what a hotfix branch is, when do you create one, versus when do you create a feature branch. Do we need a bug fix branch? If yes, then what would that look like, right? What's the process of what branch would I branch off of for a bug fix branch? Is it develop? Is it feature? Is it main? Is it release? So you'll have to come up with some common terminology and understanding of for what purpose you're creating what branch, and how would you want to review or provide feedbacks to such changes, and what does the deployment cycle or SG cycle look like for such a change. Like hotfix branch needs to be reviewed immediately, and it needs to be tested thoroughly, and it's ideally needs to go to production within like days, because like it's priority. But a feature branch can sit, people can take some time to go back and forth, review it, test it, and then they can stage it for release. So that's the understanding. If the hotfix branch has to be prioritized, so stuff like that. Depending on your branch, like it's aligned with the processes and best practices or engineering practices you have within the teams as well. Like I said, additional complexity when your releases are numbered. If you're releasing frequently, you would want to version your releases. And if you are using the Git Flow, you will have, like, you see, like there are like 5 red dots right in the diagram. For release 2.1 itself is like release 2.1.0, release 2.1.1, 2.1.2, and then you have release 2.2. So like, how to differentiate between different 2.1 versions versus what does 2.2 mean, right? Like, what does versioning for even just a release branch within your engineering team means. So you'll need to understand that. Otherwise, you're just confusing and you're just creating extra burden for engineers to like focus on, right? So you would not want to overcomplicate it. Again, multiple versions of an application are published. This can cause confusion. So let's say all the release versions are being deployed. Right now, I need to create a feature branch or bug fix branch. Should I create off of release version 2.1.2 or 2.2? Like, how do I know, right? Like, who can I consult? Like, is there a process where I can just know what version to branch off of? Should I branch off of main or develop? Is it a bug fix? So like, again, there are some best practices, but this process is so flexible, and every team or org can come with their own understanding or implementation of Git Flow, and they can like let's say we never had a master, right? But here you can see at my previous company, we never used master, but we used to have a lot of different release versions, like we show in the diagram. So we don't need a master branch, or we never had a bug fix branch. We would have either feature branch, develop branch, or hotfix. So fine. So let's not call any branch a bug fix branch. Let's just call all of them a develop or a hotfix, or a feature branch. So you can come up with all of that. And there are different arguments and pros and cons as to like what names you want to give and what works best for your org. If your team never has to do a hotfix, you don't even need a hotfix branch, right? Because that's just not the use case. So you have to understand this, and it's like super flexible, a process or recommendation. And of course, through iterations, through feedback, you can also even change this process. Like we had this, is my previous company, we had this process, we did it for 3 years, and then we decided that the team has shrunk a bit, we don't need this process, and we totally got rid of it. So like that is also like possible. One example then would be like, again, diagrams, right? Visualization helps. In this diagram, if you see like, we have a master branch or a main branch. You branch off of it, you create your own different branches, you basically commit changes, you create a pull request, you get a feedback, and you merge that develop or development branch to your main, right? But in between this, like in parallel, if you see that in the first diagram, the 3 dots at the top, other people have also branched off of your main or master branch. And these are 3 different branches that other engineers are working on. And all of this is happening in parallel. Or your master branch had like 3 new commits, right? And when you merge, now you need to also accommodate for all the other changes that happen. So like, yes, it will help you do like isolated development, but when you're merging, you kind of need to like accommodate for, like all the other changes that happen in the meantime. And this is where developer collaboration comes in handy, and testing, but also GitHub will tell you, hey, between the last time you checked out this branch and today when you're pushing your commits, 3 things changed, 3 commits were made. So you need to get the latest code, and you need to accommodate that. And if someone were to make those commits in the same piece of code that I'm making changes in, then there's a merge there's a merge conflict, and then I'll need to resolve it. And then I'll have to work with an engineer as to like, hey, this is the changes I made, this is what you made, let's talk it out. Or either Git will do it for you if it's very simple, or if it's very specific to some business logic or it's complicated piece of code, you'll actually have to reach out to an engineer who made those commits in the meantime and like resolve this merge conflict. So stuff like that. And the second diagram, you can see basically, like master or main branch has its different versions, but you can branch off and create as many different feature branches or bug fixes branches, and all that code eventually goes to your master or main branch. This is simplified for a version. We don't have hotfix branch, we don't have release branch, etc., or develop branch. So it can be as simple as just have 3 branches, like your master or main, bug fix, and feature. And if that works for your team, if that's simple and that's good enough, then you can just totally do that as well. It's just different versions, different kind of implementations of your Git flow. I think in summary, all this helps definitely improve like the integration, the continuous integration, continuous development process. It makes the development time shorter, reduces some branching complexity, because these are just like branching strategies or recommendations, and supports more focused, isolated development, and just better collaboration within engineers and different engineering teams as well. And in summary, here is just version control is what we track. We manage code. Git is just a distributed VCS for simultaneous code development. GitHub is just an online platform which hosts all your code and gives a lot of features out of the box to help you manage your code and do all sorts of integrations, testing, monitoring, etc. And help with code reviews and stuff like that, and quality control obviously. And Git Flow is just branching techniques or strategies to just simplify version controlling, code tracking, and continuous development. So this is the end of the session. This is the last session of the year. Like I mentioned, this presentation and all the presentations we do are on our GitHub repo. I will just share the link to those repo shortly. And this presentation is being recorded, so you should find it on the WWCode YouTube channel. And we already have scheduled events for the next year from January to June, and all those events can be found on the WWCode San Francisco meetup page under the event section. So do check us out and do RSVP. The next sessions we have in Q1 next year are on system design. So I'm going to do a 3-part series, one each month, and we're going to look at the first session would be about system design. Next is what are the design considerations when you are designing complicated systems where you have to think about scale, reliability, data modeling, etc. And part 3 would be looking at real interview questions. When backend engineers usually do interviews, even if you're senior or junior or even staff, you basically system design is a core interview in even before on-sites as well. So we would just want to go through some interview questions, theory and practice. So we actually solve interview questions, something like design Airbnb or design Pinterest or stuff like that. And some more links to WWCode events. So you can find this presentation and you can always click on these links and join us. Now is a good time for a Q&A. I have one question from Nisreen, if I pronounced it correctly. Sorry about that. You've only worked on group projects with small teams. How are merge conflicts handled in mid-size or big companies? So usually GitHub, when you push a code online, GitHub detects changes. It will scan your code changes and it will tell you upfront that, hey, there's some merge conflict, something was changed, and can also point you to the changes and the commit. So that's one way that visually you can just see it. And if GitHub is not able to do it, then what happens is that when you're trying to basically merge your commit to main, it will break at that point, because some other changes were made in between your changes and what's there on the main branch. So it will block you from merging, and that's where it's a great feature of GitHub. And even if you download such a code after there is a merge, you can see in your local ID, Git will basically highlight your line or different lines of code, and it will tell you, hey, here is a merge conflict, and it will literally give you the ID of the different commits, and then you can track and you can see, and then you can just pair program or reach out to someone who has made those changes and just like collaborate and talk it out. So that's why using an online platform like GitHub really helps, because it has simplified this for you. It keeps a track of all the changes at a given time. So that's one of the great features. I hope I answered your question. Great. Let me quickly share a link to our resources before I forget.
Prachi, I have a question regarding this. When we made the changes a long time ago, like around 3 months back, and we want to merge those changes to recent ones, so what should we look out when the changes are being merged? Like there shouldn't be any issues. Like let's suppose it was a web application, and you don't want the web application to not able to loop, means it doesn't face any issue while we want to make the application up or something when we are merging those changes.
Can you just phrase it in like one line question? I don't think I understood it properly.
Like if the changes were around 3 months ago or some time ago, so when we make the merging, so what things we should make it like clear when we are merging, like what should we look out for the files or for the changes, or what should we make him?
Yeah, so basically you just like want to get first of all the latest code from Git, and that's when you have the latest code to work with. Merging only happens when, let's say, both of like you and I checked out the same branch and we are working on the same branch in parallel. I submit something and you submit something, and then only one, if it's like overlapping piece of code, then GitHub will tell you, I see different changes on the same piece of code by different engineers, and that's where it will tell you merge. Merge usually happens when I got like I downloaded like my I branched off of main today and I push my changes tomorrow, and in between today and tomorrow you push your changes and they're on main. Now I don't have the latest code because you modified that piece of code or that file, and my file looks very different from your file now because you changed the contents, or you even deleted the file. So there will be a merge conflict because if you deleted the file, GitHub will tell me there's no file for you to make those changes. Or if I'm modifying the same content that you updated, GitHub will tell me like you have an old copy of the code, like Anjali updated the code, so you need to get the latest code and then add your changes to it. So this is basically like two scenarios where merge happens, and GitHub will tell you, and it will point out in your local ID. It will download the merge conflicts locally, and it will show you in the code. It will literally highlight it, and that's when you know that like these few pieces of code have changed, and therefore you need to get the latest code and then make your changes. So you'll do a git pull, you revert your changes, then you do a git pull, and then you would want to add your changes. Yeah.
Thank you.
Yeah, let me share some links. Anjali, do you want to share a link to your LinkedIn? You can feel free to like reach out to me or Anjali on LinkedIn, and I just shared like a few links to our resources. And if you do, we would really appreciate if you just fill the feedback form and give us like your feedback. And if you have any ideas or suggestions or some topics you want us to do a presentation on, do share with us. And I shared a link to our Slack channel too. It's an invitation. We have a backend study group channel, and you can definitely like join, ask questions, share resources. We would really appreciate that. Anjali and I'll be here for another few minutes. Feel free to ask questions. Otherwise, thank you, everyone. We're really thankful you joined us, and we really hope to see you next year for all our events, and happy holidays.
Prachi, I will stop the recording now.
Yeah, good idea.